We always talk about the highest mountains or the biggest planets, but today we're flipping that on its head. We're taking a tour of the solar system's most extreme depths. We're talking places of crushing pressure and ancient, ancient mystery. We are going to the bottom.
So let me ask you, what is the deepest place in the solar system? Now, you might have an answer ready to go, but the truth is, well, it's way more complex, and honestly, way more fascinating than just a single spot on a map.
Here on Earth, the answer's pretty straightforward, right? It's the Challenger Deep in the Mariana Trench, this incredible abyss carved by plate tectonics. That's our yardstick. But the second we leave our home planet, the very definition of deep starts to get fuzzy.
That's because out there in space, deep isn't just about a hole in the ground. It can mean a gigantic geological canyon, or a layer of atmosphere so dense it crushes you, or even a gravitational well so intense it literally reshapes matter itself. And today, we're exploring all of them.
Okay, first up, let's talk about the great scars of the solar system. These are the depths carved into solid surfaces either by massive tectonic forces or by ancient, incredibly violent impacts.
Our first stop on this tour is Mars. It's home to a feature that people sometimes call the Grand Canyon of the solar system. But let me tell you, that comparison doesn't even begin to cover it. Not even close.
So get this, Valles Marineris plunges down about 11 kilometers. That puts it right on par with our own Mariana Trench, but its depth, that's only a tiny fraction of what makes this place so absolutely incredible. The thing that's truly mind-boggling is its length. At 4,000 kilometers, this canyon system stretches across almost a fifth of the entire Martian circumference. It wasn't carved by water. Nope. It was most likely ripped open as the planet's crust stretched and cracked under the sheer weight of colossal volcanoes billions of years ago.
So Mars's great scar came from forces within the planet. But other worlds have these deep wounds that were caused by violence from the outside. Take Mercury, it's got the Caloris Basin. And our own moon has the South Pole Aitken Basin. Both of these are just colossal scars from the chaotic, early days of our solar system.
You can really see how worlds get scarred in different ways. Valles Marineris shows us a planet that basically tore itself apart from the inside out. But the basins on Mercury and the Moon, they are pristine records of cosmic catastrophes. Impacts so powerful they just blasted the crust away, leaving behind depths of 8 to 9 kilometers that have sat there almost unchanged for billions of years.
All right, let's switch gears completely. We're leaving solid ground behind now, and we're about to venture into a totally different and maybe even more alien kind of depth, the abyss of atmosphere and crushing gas.
And here is the key difference you gotta get. The depths we've seen so far are physical canyons. You could theoretically stand in them. But atmospheric depth, that's a descent into an invisible ocean of gas, where the bottom isn't a floor. It's the point where the pressure just becomes unsurvivable. And there is no better example of this than Venus. We sometimes call it Earth's twin, but its atmosphere is a runaway greenhouse inferno. It creates an abyss of pressure that is so much deeper and more hostile than any trench we have on our planet.
A journey to the so-called bottom of Venus is a death sentence. The Soviet Venera probes that actually tried it sent back a truly chilling story. As they went down, the temperatures just skyrocketed past 460 degrees Celsius. The pressure built up and up to over 90 times the pressure we feel at sea level on Earth. And just like that, within minutes, the probes were crushed flat, totally silenced.
To try and put that into perspective for you, standing on the surface of Venus would feel like being a full kilometer underwater here on Earth. It's an abyss made not of rock, but of a superheated, supercritical fluid that we just happen to call an atmosphere. And that brings us to our final destination, the king of all depths, Jupiter's seemingly bottomless atmosphere. On this world, the very concept of a surface is pretty much meaningless.
58 minutes. That is exactly how long NASA's Galileo probe survived its plunge into Jupiter way back in 1995. It was battling incredible heat, incredible pressure, and it only made it less than 1% of the way to the planet's center before it was just completely obliterated.
On Jupiter, depth isn't geological, it's physical. It's not about falling toward a floor, it's a plunge into a gravitational well so profound that it literally reshapes matter. Gas becomes liquid, and that liquid becomes this bizarre state of matter called metallic hydrogen. This is an abyss of physics itself.
So, after taking this tour of these incredible, unbelievable abysses, what have we really learned? Well, these deep points aren't just curiosities on a map. They're like windows, giving us a peek into the very souls of other worlds.
Each and every one of them tells a story. Valles Marineris shows us a planet's violent geological history. The great impact basins are like fossilized scars from the moment the solar system was born. Venus is a serious cautionary tale about a runaway greenhouse effect. And Jupiter's abyss? It's a laboratory for a kind of physics that's still beyond our comprehension.
These extreme depths, they really push the limits of our exploration and, frankly, our imagination. They remind us just how diverse, how violent, and how wild the cosmos can truly be. For now, we can only really study them from a distance, and that just leaves you wondering, right? What other secrets are still locked away down there, just waiting for us in the deepest places in our solar system?